Recent innovations in AI-driven surveillance systems are profoundly reshaping how these technologies interact with users. Designed with a human-centered approach, these new systems aim to optimize both technical performance and user trust. Jeesmon Jacob's research focuses on aligning algorithmic precision with human behavior, offering smarter, more adaptive, and intuitive security solutions. Under resource constraints, one of the key challenges lies in hardware limitations. Real-time detection and threat analysis demand significant computational power, leading to reduced battery life and thermal throttling in critical environments. These performance issues can undermine system stability and detection accuracy. Lightweight models like MobileNet SSD offer viable solutions by maintaining solid performance while improving energy efficiency, making them well-suited for edge deployment in resource-constrained conditions. Efficient compression. Without losing clarity, to make AI more viable on edge devices, advanced neural network compression techniques have been adopted. Methods like model quantization and binary networks have reduced memory usage by up to 85%, while maintaining high accuracy. These compact models enable surveillance devices to perform complex tasks with significantly lower energy consumption, shifting the development paradigm towards sufficiency rather than excess. Addressing alert fatigue. An underestimated challenge. False positives are more than mere annoyances, they gradually erode user trust. After receiving too many incorrect alerts, users often disable notifications or reduce system sensitivity, compromising overall security. More advanced systems now incorporate intelligent filtering mechanisms that adapt to both user behavior and environmental context, distinguishing real threats from routine activity using time-based patterns and historical data. Trust beyond accuracy. Interestingly, perceived reliability doesn't stem from perfection, but from balance. Systems that issue occasional false positives, if done in moderation, are often viewed as more attentive and reliable. This counterintuitive effect is tied to psychological confirmation bias. Occasional alerts serve as reassuring signals of system engagement. UI design is now evolving to reflect this insight, prioritizing visual evidence over textual classifications, as users respond more intuitively to images when evaluating the legitimacy of an alert. Adaptive resource allocation, a new metric for efficiency. Where traditional systems rely on static resource allocation, modern adaptive systems respond dynamically, ramping up processing during critical moments and conserving energy during routine surveillance. This approach has demonstrated a 23% improvement in the trade-off between accuracy and performance, particularly in unpredictable or high-variability environments. Interfaces that speak the user's language. User-system interaction has been reimagined to prioritize clarity and ease of use. New interfaces avoid overwhelming users with complex settings, instead offering predictive visual feedback. For example, the system may show how changing a setting will impact battery life or alert frequency. This transparency enhances engagement and reduces abandonment rates, strengthening overall system effectiveness. Bridging the gap between expectation and reality, users often overestimate AI's discriminative power while underestimating its sensitivity to environmental variables. To bridge this gap, advanced systems subtly educate users through transparent feedback that both informs and recalibrates assumptions. Studies show that such transparency leads to higher adoption rates and long-term user engagement. Ethics at the core, not an afterthought. Ethical considerations are now a fundamental requirement. Transparent data practices, privacy by design principles, and granular user control are no longer optional. Users are more likely to trust and consistently engage with systems that clearly communicate data usage, offer opt-out mechanisms, and embed ethical safeguards by default, toward empathetic and context-aware surveillance. Ultimately, AI-powered surveillance must evolve from passive observation to contextual understanding. The goal is not just detection, but interpretation. Future systems should combine technical precision with perceptual sensitivity, becoming reliable allies rather than intrusive tools. As Jeesmon Jacob emphasizes, success lies not in complexity, but in thoughtful integration that respects both artificial intelligence and human behavior.